Hi, my name is Kai Sisk. I am a junior here at HumeFog, and I am here to talk about graphing polynomials. So graphing polynomials is relatively simple, and there's a few steps. First things first is, let's start off with just an example polynomial here. So the first thing we're going to do is determine end behavior. So there's a bunch of ways to do that, but one of the easiest ones that I found is I have a handy little table here. And so what we have with this table is we need to find, as I was saying, we need to find the end behavior. So there's a few things we could do. First of all, we need to find the largest exponent and its parity, which is a fancy way of saying whether the largest exponent, in this case 3, is even or odd. And the other thing we need to find is if the coefficient is positive or negative. In this case, it is negative, as it is negative x cubed minus 2x squared plus 8x. So positive or negative. So here's how end behavior works. We're trying to find out where the function goes after we graph the center of the equation, which is where the thing is. Does it go towards, which way does it go towards infinity in the y, or negative infinity in the y-axis? So with this table, if the function's largest exponent is even and the parity of the coefficient is positive, from the left it will approach positive infinity in the y-axis, and from the right it will also approach positive infinity in the y-axis. And if it's odd and it's positive, you will have negative infinity in the y-axis from the left and positive infinity in the y from the right. Even negative is negative infinity from both the left and the right. And odd negative will have infinity from the left, and negative infinity from the right. So to work through this function, we have an odd largest exponent and we have a negative coefficient. So we will approach positive infinity from the left and negative infinity from the right. So, as we can see this, next thing we have to do is find the y-intercept, and this is very easy. What we do is we take our equation, and so in this case y equals negative x cubed minus 2x squared plus 8x, and then we set x to 0, and then we solve for y. This is basically just find any term that does not have an x in it, and that is your y-intercept. Just combine all those terms. So in this case, our y-intercept is 0, as if you solve for x here, you would get 0. So here's the hard part. So here we have to find the zeros, or the x-intercepts, and there's a few things we can do. The first thing for this one that I'm going to demonstrate is we can take out the greatest common factor. So in this case, take a look at this equation. What we have to do here is set y to 0 and solve for every possible value of x. So we get 0 equals, so as we can see right here, we have to solve for x. So if you can notice here, every single one of these terms has an x in it. So what we can do here is we can do this. So now we have x times this equation. So what we can do here is, using this greatest common factor, we can now factor this equation, and I trust you know how to do this, with just multiplies to negative 8, adds to negative 2, so that would give us negative 4 and 2, so we get 0 equals x times negative x squared plus 2x minus 4x plus 8, so we can do 0 equals, we get negative x times x minus 2. So, and then we have negative 4 times x minus 2 times x, and then we get, so now if we simplify this equation, it's x times negative x minus 4 times x minus 2. So what we get for our zeros here, we get 0, we get 2, and in this case we would get negative 4. and these are our zeros. So now we know our x-intercepts, our y-intercepts, and our end behavior. So our function, if we're graphing it like this, would look something like this. Now, this is not drawn to scale, obviously, but it would look something like this. You don't need to get the exact points because that requires significantly more in-depth detail, and that is something we are not going to be doing yet. So there is another important way of finding out zeros. So I'm going to pull out a different example function. In this case, we're going to be using negative x cubed plus 2x squared plus 9x minus 18. So right here, we'll do finding the end behavior and stuff later because we're going to go straight to this. One thing we can do here is that we can't take out any common term, largest, greatest common factors. But what we can do is separate it into these two things. And from these, we can take out greatest common factors. So for example, if we can take x squared out from here and get negative x plus 2. And then we can take out x squared from here and get negative x plus 2. And we can take out negative 9 from this one and get negative x, that's a 9, get negative x plus 2. And so now we can separate this down into x squared minus 9 times negative x plus 2. And from here, we can separate this equation further. If we factor this further, we get x plus 3 times x minus 3 times negative x plus 2. So our zeros here are negative 3, 3, and in this case, that would be 2. So here are our zeros for this equation. So now if we can then go back and find our end behavior, which in this case is again positive infinity from the right, negative infinity from the left, and we can find our zeros, in this case negative 18. So if we graph this function, it would look something like this. All right, so thank you for watching this video. I hope this helps, and good luck on midterms and final exams.